audience will be here comfortable sharing a good time here this morning. Let me now introduce you to Professor Javier Segovia, Dean of the Facultad de Informática, who will act as the chairman of this workshop. And additionally, I have to comment a civil answer because we have yesterday a terrorist attack. It will be held at 11 o'clock, a minute break, in which we will remain in silence. Okay? So,
thank you, Professor. Okay. The first speaker is Nicolas Spyratos, okay, from the University of Paris. And we thought that we have 30 time for each one, but I think maybe we are a bit short of time, so we will leave it in 25. You can do it.
I will stop.
Yeah, okay. There's been many questions.
I would first of all like to thank Professor Rafael Fortaita for inviting me here, as well as the chairman of this department and all my Spanish hosts. I'm very pleased to be back to Madrid after 20 years. And as we are really pressed in time, I will go directly to the subject, which is information access data preferences. This is one aspect of what we call today information personalization, and which has many different aspects. One of them is being based on preferences. So I would like to ask with this phrase that I have seen in the recent issue of Wired, which says basically that before we're going from theory to data, and in recent years, everything starts with collecting vast amounts of data and going out to the field. So this happens since a few, let's say a decade or 15 years ago, it started to happen. But there was a poet by the name of T.S. Eliot, British of American origins, that had said that much better, much before. Where is the wisdom we have lost in knowledge? Where is the knowledge we have lost in information? And we may ask, we may add rather, now, and where is the information we have lost in data? So now, because again we are pressed in time, with a big jump from poetry to a completely unpoetic field, which is computer science, let's go then to the casual user of a large database who is wondering how to extract information from the data stored in that database. And all he wants, because he's casual and not professional, is a way to define the data needed. Therefore, what we call in computer science jargon, a query language. And once this data is brought back to him, or to him, it should be customized in a way, therefore, that corresponds to the specific preferences. And this is what we mean by personalization. So incorporating the preferences of a user as to the presentation of the results in the dialogue between user and computer is one way of achieving personalization. There are others. We first came into this problem in the context of a European Network of Excellence called DILOS, which lasted 7 years, and where, among other things, we had to, at least in my group, to deal with this kind of problem. So, another big jump directly to a concrete example, which are the electronic catalogs that one finds on the web. And the best example I have to offer is a French one called Auto Reflex for selling used cars. So this information that you see there is more or less what you find on the web. Every line corresponds to a used car for sale, and there may be several thousands of entries, and just before vacation time in summer, several tens of thousands, because French usually sell their cars to go on vacation. So, in this kind of phase, the data needed by the user is defined by a Boolean combination of simple expressions. This is what they call, or we call, keyword-based search. And we have an example on the bottom. The query there for Q says, I would like to see BMWs or Volkswagens. But there is a problem. When the table, as I said, contains several thousands of entries, then the answer, more often than not, might be either very small and therefore not satisfactory for the user, or very large and therefore difficult to exploit. So the user solution is changing the query, replacing, for example, disjunctions by conjunctions. But very often the solution to either of these problems by changing the query leads to the other problem. So if it is very large and we replace disjunctions by conjunctions, we may get no answers, and vice versa. So the question is, if the answer set is very large, can we help the user to consume, i.e. to exploit fast the answer set without changing the query, assuming that the query is exactly what the user wanted? So one possible solution is to partition the answer set in a way that the first block contains the best elements of the answer, best according to preferences, the second best, and so on. So assume this query Q, which says I want BMWs or Volkswagens with less than 40,000 mileage, and assume also that the answer is this numbers I give there. So what we would like to do, if the user expresses the preferences, I like BMWs more than Volkswagens, on top of the query that he put, then the solution proposed is to present to the user the BMWs first. Probably he will find the car he wants there, and then the W's. 3 questions have to be answered in order to do this. First of all, what kind of preferences a user can have. Second, how he can express them in a computer. And third, how can you incorporate them in the query processing or evaluation of the query. So let's take them one by one. The kinds of preferences that have been observed, there may be others, and there are, they differ in terms of their nature. They can be classified into qualitative and quantitative, And the quantitative are of the sort, I like BMW 80%, I like Volkswagen 70%, but these are preferences that are typically difficult to express by the user, easy to express by machine, because machines can exploit query logs and find out what is the frequency of asking for things. Qualitative preferences are more suitable for a user because all he has to say is, I like BMW more than Volkswagen. As you notice, I only use non-French examples. No Renault, no Peugeot there. In terms of the duration in time, the preferences can be long-term, and they are discovered by the system without interference to the user's activity, or can be declared explicitly by the user, and in both cases, they are stored in the so-called user profile, which is therefore taken in conjunction with the query posed by the user. Short-term preferences are those that are expressed online, and this is the case that is of interest to us. Therefore, short-term preferences, quantitative nature, and this kind of problems and preferences have been studied for decades in economics and in decision-making in general, and it's only recently that they made their appearance in computer science. So, first, what kind of preference can a user have? A way to express, as I said in the example, the qualitative preferences is to give a pair of values in a column of the table that we saw at the beginning. So BMW, arrow, Volkswagen means that I prefer BMW to Volkswagen. If you have a set of such pairs, then you have a graph, like the one you see on the bottom. And I note at the end that no assumption is made on the preference relation. This is because we don't want to burden the user with constraints when asking questions. So this is how one can express preferences. These are the easy questions. The hard one is how can we embody them in the query evaluation. And here is a very dense slide. The notion you see on top, preference query, says that preference query is a usual query plus a preference relation. So if you consider this query and assume we have this answer and these preferences expressed on the model column, then this pair is a preference query. So in a nutshell, here is what we do in order to answer this query. We take the preference graph and we do a so-called topological sorting, which creates a sequencing of nodes of the graph. So BMW and Toyota are the first ones, followed by Volkswagen, followed by Honda. Now, once this is done, then one, in theory, selects from the answer set first the BMWs and Toyotas, guided by this sequence, then the Volkswagens, and finally the Hondas. Now, the big question is, can we rewrite the query given so that these sets here are the answers to a sequence of queries? So we rewrite the query into a sequence of other queries. And here you see schematically how we do it. Once we put the topological sorting, then in each group we have non-comparable in terms of preferences nodes, and therefore we consider this function for those, and we end up with these three queries that must come in that order. So, however, each of these queries might return things that do not belong to the answer set of Q. Therefore, we take conjunctions between each query and Q. And at the end, whatever is left will be presented last. So, in this way, we obtain rewriting of the query into a sequence of queries that produce the blocks we were talking before. The computational complexity is quite insignificant. It's linear to the number of nodes and to the number of edges. And this size is usually very small because preferences are not very large in number. So schematically, this is what you obtain. In the middle, you have this big circle is the query, and then whatever intersections we have with the small queries, let's call them small, give you the final result, which you see here. And the first in the sequence, the first query in the sequence, is what in data warehouse jargon called the skyline query. So once we have settled these three questions, how much time do I have?
10 minutes.
10 minutes, okay. So I will finish earlier. There is one problem remaining, as we have put no constraints to the user dialog. The user might create cycles, and the sequencing of queries requires an acyclic graph, otherwise we cannot perform topological sorting. Here's an example of a cycle, BMW before Volkswagen, Volkswagen before Honda, and Volkswagen before BMW. So what do we do if such cycles exist in the preferences expressed by the query? And there are two ways of going about it. We can either ask the system to eliminate cycles by considering that all elements in a cycle are equivalent in terms of preferences. And there's another method. So the first method is automatic processing of cycles. The second method is to ask the user. The system computes the cycles, presents them to the user, and the user decides whether he wants to break the cycles or not. So for this, one needs algorithms for finding all cycles in the preference relation, whether we apply the first or the second method. So, so far I gave you a hint of how things are done, but the problem is quite more complicated because, of course, we do not only express preferences in one column, like I prefer BMWs to Hondas. We may want to express preferences at the same time of a color. I prefer red to white. And when this freedom is given to the user, then we are, of course, forced to ask the user whether he prefers color over model or model over color. Therefore, a lexicographic ordering of columns over which preferences are expressed. A second possibility is that the user considers all columns of the same weight, and in this case you have the known to economists and social scientists Pareto ordering. So when all this is taken into account, you have quite complicated problem with a slight mathematical hue. And for those that are interested in this kind of problems, there are two papers from my group in this year's International Conference on Data Engineering and the Conference on Design of Communication. So, as concluding remarks, I would like to insist on a few things which I consider as the pluses of this approach. First, incremental evaluation of a query. What I mean by that is that a query or the query, along with the preferences, is split into a sequence of subqueries. If we therefore equip the interface with a next and stop button, then under the control of the user, we may answer the first query. If the user is satisfied with the results, then he can stop the process, otherwise continue. This means that if the preferences of the user are expressed in a way that really reflect what he has in mind, then most likely the first subquery would be sufficient, and therefore the system would not have to evaluate the rest. The second thing that I consider as a plus is the unconstrained preference expression. By that I mean that the user doesn't have to do anything more than express his preferences. The system will take care of the rest. Now, the little minus I have put there have to do with cycle treatment, which needs to be improved in the interface that we have developed in our group. The treatment is automatic, but we would like to involve the user in this breaking of cycles, if cycles exist. The second minus is lack of experimentation. We have done some experiments within the project, but not in the labs. In other words, we have not seen what happens with choices when we contact travel agencies, where we have to express preferences of the sort. I would like a hotel not far from the beach, and so on and so forth. And the last one, there are 3 points that I would like to mention here. These are the missing values. What happens to this approach when the so-called, in databases, null values are present? The second is more subtle, need for a preference specification language, which means that we never said what happens outside the columns over which preferences are expressed. And if you know the term ceteris paribus, this means that if we don't say anything about what happens outside the columns over which we express preferences, then we may end up with surprises. In other words, when we say, I prefer BMW to Volkswagen, in the back of our hand, we have the idea that for equal price, okay? And this is what is not expressed in this kind of approach. So you need a language which can precisely say what happens not only
over columns over which preferences are expressed, but also over the rest of the columns. And finally, I'm saying hard versus soft constraints or query versus preferences. As you have seen, in defining the subqueries, I privileged the preferences, but one may as well privilege the main query and not the preferences. So these are the assumptions that are tacit and we are currently investigating. And this is the end that you can read from top down for Japanese and from left to right for Europeans. Thank you.
Thank you very much. I think I have 1 minute for questions, if anybody has one. No? Okay. Thank you very much. Thank you.
Thank you.